We have a lot of people who do recombinant DNA work here at the university who work with adenovirus and lentivirus. So this is your typical BSL-2 lab. It's a little bit more involved than a BSL-1 lab. Sometimes it looks similar to a BSL-1 lab, but the work practices are different. But a lot of times you will find a general BSL-1 lab, and then you'll find a lab that looks like this, maybe across the hall, which is their tissue culture room. And that's their BSL-2 area. And it's a smaller lab where the door's shut, where they have their biosafety cabinets, their centrifuge, their incubators. That's a more typical setup. But some people have a large lab that they've just designated everything in there as BSL-2. Requirements for a BSL-2 lab: the lab is separate from a public area. Not only do you have to have a door, but it has to be lockable. Okay, so a little bit different from a BSL-1 lab. Reason for that is when you are away from a BSL-1 lab and it is unattended, or BSL-2 lab, it's unattended, it has to be secured. Your risk group 2 agents must be secured when left unattended. That can be accomplished one of two ways. You can either secure the incubators, the freezers, the refrigerators, any place that you are storing the agents, which some people choose to do that, but that can get tricky if you have stuff in incubators. People don't like to lock up their incubators. If you've got everything at a -80, that works fine. Or you lock the lab, which is more typical. You have to have a sink for hand washing. Your work surfaces have to be easily cleanable. You cannot have any fabric-covered chairs in a BSL-2 lab. Reason being, if you were to have a spill, say of some tissue culture media, you have to be able to decontaminate your furniture. And if you have a fabric-covered chair or even something that's wooden, the liquid is going to soak right down into your chair. Obviously, you can't decontaminate that; you have to throw it away. So whatever you have has to be wipeable, cleanable. It can be vinyl, it can be plastic. Some labs, if they have fabric-covered chairs and they don't have the funds to go out and purchase all new chairs, we've given them kind of a cheap, quick fix until they get funding available. You can go to Home Depot or Lowe's and buy contractor garbage bags. They're that thick mill plastic, and you just put them over the chair and tie them at the bottom. Then if you have a spill, you just take the garbage bag off and put a new one on. It's not pretty, but it works. So we do have some labs that do that, and that, actually meets the definition of what you need. But we do prefer that you have a chair that is able to be decontaminated. Most BSL-2 labs are going to have biosafety cabinets available. If they're doing any procedures that can generate aerosols, things like pipetting, shaking, vortexing, anything like that, homogenizing. If they're doing anything with vacuum, the vacuum lines need to be protected with an inline filter and a disinfectant trap, especially if they are connected to building vacuum. We need to protect the building vacuum from anything getting sucked up into the system. We want to make sure you have adequate illumination, adequate lighting. We don't want you working in the dark. BSL-2 lab, you have to have an eye wash available. We didn't need this in a BSL-1 lab because mucous membrane exposure was not a problem. But in a BSL-2 lab, we're working with risk group 2 agents. Mucous membrane exposure is an issue. So we have to have an eye wash readily available. It does not have to be in the lab, but you need to be able to reach it within 10 to 15 seconds. So some of the buildings, the eye washes are in the hallway. That's fine as long as it's close and you can get to it without having to go up or down a flight of steps. If you have to go up or down a flight of steps, that's not acceptable. Then you need to put one in your lab, and they can be fitted to your sink. But if you get something in your eye, chemical or biohazard, you definitely want to have an eye wash available. You also want to test your eye wash. We recommend weekly that you just turn it on and flush it, maybe for a minute or so, and it flushes out any, standing water that are in the pipes, any rust that may be in there if you let it sit for too long. Because if you actually need that eye wash sometime, you don't want that blowing into your eyes. If it's been sitting there for a year and nobody's turned it on, and then you splash a chemical in your eye and you go over there and turn your eye wash on and it blows brown rust into your eyes, that's not a good thing. The last thing for a BSL-2 lab, airflow into the lab should be, or the airflow should be into the lab, which is called negative pressure. And there should be no recirculation into non-lab areas. So from the hallway, this is your public hallway, all of the air is going to flow from the hallway into the lab and then out through the exhaust, which may be the fume hood or maybe just your normal room exhaust. Special practices for BSL-2, we need to limit access to the labs. The doors need to be kept closed when you're working in a BSL-2 lab. You need to have initial lab-specific training on potential hazards, and your PI or whoever you are working with in the lab can do that training. It needs to be documented. You should have any appropriate immunizations when you start. If necessary, if you're working with human source material, you need to be offered the Hep B vaccination. Again, no eating, drinking, storing food in the lab. You should work in a biosafety cabinet when there's a potential for aerosol production. If you're doing work that doesn't produce aerosols, you can do that on the benchtop. So if you're doing things like DNA or RNA extraction, running gels, that kind of stuff can be done on the benchtop. Work surfaces should be routinely disinfected and decontaminated after any spill with an appropriate disinfectant. Appropriate disinfectant is 10% bleach, a 10% bleach solution, or any other tuberculocidal disinfectant. And to find that out, just look at the label. Things like Wexide are fine. There's some other ones that people use, but sometimes people don't like using bleach. Most people use bleach. It's super cheap. You can go to Meijer or whatever and buy a bottle of bleach for $1, and as fast as you go through it, it's the disinfectant of choice. But it's also corrosive. So if you're using something, or you have surfaces that corrode easily, bleach may not be your choice. You want to make sure you're wearing your PPE and you're handling sharps with care. If you are transporting any risk group 2 agents between BSL-2 labs or anywhere else on campus, they need to be transported in leak-proof containers, so in secondary containment. If you have test tubes, if you have plates, they need to go into something else, a small cooler, Tupperware container, a Ziploc bag, anything that is closable, sealable, and they should be labeled on the outside of the container as biohazard. So in the unfortunate event that something happens to you, you fall down the steps, you get hit by a car, you drop them, something, it's the spill is contained, or if there is a spill, people know, hey, that's a biohazard, we need to take precautions when we're cleaning that up. And then, of course, infectious waste needs to be segregated and disposed of properly. We'll talk more about that tomorrow. Biosafety level 3. Some of you at some point in time in your career may work in a biosafety level 3 lab. This is suitable for work with agents with the potential for aerosol transmission that may cause serious illness or lethal disease. Examples of this are tuberculosis, anthrax, high-path avian influenza. And this is an example of what a typical BSL-3 lab would look like. This is a high containment lab. We do have 3 BSL-3 labs here at OSU. Requirements for a BSL-3 lab, all of your BSL-2 lab requirements are still in play. but we have some additional requirements. We usually have a separate building or an isolated area within a building for a BSL-3 lab. These are very carefully designed and approved facilities. You don't just throw one of these up and start working in them. They take years to design and build. They need to be certified every year, the facility, the whole facility. They go through a very lengthy process of commissioning before they go into use. They're basically an airtight perimeter of containment. The entire facility is leak tested. So every light socket, every outlet, every around the walls, everything is sealed, so nothing gets out. You have negative air pressure with a ventilation failure protocol, and the exhaust from the facility is filtered through a HEPA filter. You have to have a pass-through autoclave on site, so everything that leaves the facility is autoclaved before it leaves. You've got a double door access or an airlock to incorporate a changing facility and a decontamination room. All work in a BSL-3 is done in a biosafety cabinet or other appropriate containment device, maybe a glove box or a sealed centrifuge, something of that nature. And depending on what you're doing, other special practices might be required. You may have to wear a PAPR respirator or an N95. It just depends on the facility. Biosafety level 4, these are your maximum containment facilities. These are suitable for work with dangerous and exotic agents that pose a high risk of life-threatening disease that may be transmitted via aerosol, and we have no available vaccine or therapy. Examples of this are Lassa virus, Ebola virus, Marburg virus. These are your hemorrhagic fevers. There is no BSL-4 work at OSU, and there never will be any BSL-4 work at OSU. I believe there are only 6 or 7 BSL-4 facilities in North America, and five of them are government facilities: CDC, NIH, USAMRIID, the Army facility. There is one private facility in Texas. They are building one in downtown Boston, which has been very controversial, the University of Boston. There's also one in Canada, at Public Health Canada. So these are very specialized facilities. And this is a typical BSL-4 facility. This is the type of facility you see in the movies like The Hot Zone or things like that, where they're working with the crazy virus that's killing everybody in the world. But they have to wear the air suits, the space suits that are connected to an air supply. Very quickly, I want to go over animal biosafety levels. We're not going to go through them all, but just so you know what they are. Some of you may do some animal work, and there is a difference between a biosafety level and an animal biosafety level. Biosafety levels you'll see are just written BSL-1, BSL-2. You may see a designation ABSL-1 or ABSL-2. That means it's an animal biosafety level. And animal biosafety levels are combinations of practices, safety equipment, and facilities that are used for working with animals infected with agents that produce or may produce human infection. Okay, so that's the key. We are worried about these animals. Say we have some mice that have been infected with adenovirus. Okay, the mice then shed the adenovirus in their feces and urine. The people who are caring for the animals, changing the bedding, the vets who are taking care of the mice, they have the potential to be exposed to the adenovirus in the bedding, by taking care of the animals. That can be aerosolized. There is a potential that if they weren't wearing the proper PPE, that there's a risk to them. So that's what an animal biosafety level is. I shouldn't say we don't care, but the concern in an animal biosafety level is not that mouse A is going to make mouse B sick. Okay? These are not zoonotic issues. These are animal to human transmission through shedding or that sort of thing. So this is the containment and the PPE that we have to worry about because we have intentionally infected an animal with something, and now we have to worry about getting it back. Okay? So the biosafety level in the lab and the animal biosafety level are not always the same. When you are working in the lab, many times there is a higher risk when you're doing laboratory work than once you put something in the animal. When you're working with human source material, for example, the risk is you're always going to be at BSL-2. Once you put human cells in an animal, there's no risk anymore. They don't shed those cells. You're not exposed to the human cells anymore. So the animal biosafety level is ABSL-1. So you may see that in an approval letter or something from the IBC or from the IACUC that says it's BSL-1 or BSL-2 ABSL-1. That's not a typo. That's just that the risk in the lab is higher than once the agent is put in the animal. Very rarely, I can't think of any instances where the risk will go up. If anything, it will stay the same. I can't think of any instance where the risk increases when you put it in the animal.